Quantum loops and reversible fates, a breakthrough in solving the central paradox of time travel. Every seasoned time traveler is acutely aware of a cardinal rule etched into the fabric of their existence: meddle not with the past. This is not just about avoiding the cliché misstep of squashing a butterfly or the grim folly of dispatching one's own grandfather. Even sipping a tea laced with polonium, a cautionary tale for another day, falls under this strict taboo. The smallest actions, like petting a stray dog or savoring a warm slice of pie, ripple outwards in ways that could unravel the delicate tapestry of history. Time travel then becomes an exercise in extreme precision, a high-stakes dance where every step must be calculated to avoid catastrophe. To navigate this minefield, travelers might rely on two lifelines: an almost superhuman vigilance or sophisticated predictive algorithms charting a pass-safe course, minimizing contact with anything that breathes, moves, or attempts the senses. Science fiction has long toyed with such concepts. One particularly clever tale imagined a returning time tourist passing through a bioscanner. If the system detected a temporal misstep, a crushed insect, or a misplaced word, it would sound the alarm, offering a chance to rewind and repair the timeline before the damage set in stone. Yet Lorenzo Gavassino, a physicist from Vanderbilt University, challenges this orthodoxy in a breakthrough study blending entropy, quantum mechanics, and the quirks of space-time. He argues that the infamous grandfather paradox, where killing your young grandfather, prevents your own birth, thus negating the act itself, might not be the cosmic dead end we feared. Far from a rigid barrier, Gavassino sees it as a puzzle with a surprising, elegant solution. Picture time as a railway looping across a vast, pliable mattress. General relativity tells us this track bends and stretches under the weight of mass and the pull of acceleration. Near black holes crushing gravity, these distortions might twist into closed time-like curves, portals that sling you back to where you began. And here the entropic arrow of time, that relentless march from order to chaos, flips and dances between the loops, entry and exit, defying your usual forward-only intuition. In stories, this sparks endless speculation, splintering timelines, endless cycles or parallel worlds blooming from every choice. But what does physics say? To unpack this, we dive into thermodynamics, the science of order and disorder, and ask what happens when a system doubles back on itself. We humans mark time's passage with memory, a luxury physics does not indulge. The laws of the universe from Newton to Einstein are largely time-symmetric. Run them backwards and they still hold. Entropy, though, gives time its direction. It's the slow crumble of a sandcastle into shapeless grains, the inevitable spread of chaos. Classical thermodynamics has tracked this for centuries, but quantum mechanics throws a wrench into the works, blurring the lines with uncertainty. Gavassino's experiment begins with a thought. Imagine a time traveler spaceship, a high entropy jumble of heat and motion, looping back to a low entropy past. Conventional wisdom says entropy should climb forever, disorder piling upon disorder. But his quantum statistical model reveals a twist. As the craft re-enters its own timeline, entropy does not just keep rising. Quantum uncertainty steps in, effectively freezing the chaos by spinning off a parallel timeline, one that shares the same start and finish but rewrites the journey. And inside this looped vessel, entropy's rules bend. Processes we'd call irreversible, like a grandfather's death, might flip, becoming malleable. Step back to a moment where your young grandfather tends to your grandmother, and the loop could undo his demise. Your motive for murder wiped clean as if it never was. The spaceship's content, its crew, its clutter, exist in a strange stasis, neither fully past nor future, but a quantum echo of both. Gavassino is not the first to probe the time travel through a quantum lens, but his work ignites fresh curiosity. It's not a blueprint for DeLorean or a TARDIS. It's a window into the universe's deepest mechanics, time, space, and the shadow's possibility. Compare this to the science fiction of infinite parallel universes. Step outside in sneakers and the cosmos blinks into being where you choose boots instead. Gavasino's math takes it further, grounding in quality reality. Each action in a time loop does not just spawn new worlds, it reshapes the one you are in subtly and seamlessly. So time travelers might breathe easier, the butterfly can flutter on, the pie can stay uneaten, and the grandfather can live, at least in one version of the story. Gavasino's work does not promise a ticket to 1885, but it does invite us to rethink the rules of the game, bending rigor with wonder in a way that keeps the universe's mysteries tantalizingly alive. This is on Soul Ask. Please leave your comments, and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.